Hello everyone, my name is Ana Paula. I am an inventor, a data scientist, and a research, and I work in the client engineer unit at IBM Brazil. So today I will present a little bit of one of my works, and the title of my presentation is Connecting the Dots Between Industry and Research. We all know the difficulty of publish some work that we do, especially in industry and industry research or applying research, sometimes in big conference. So, what is the main point here? So, when we work with direct with clients, sometimes the work that you do is not published. Why? Because it's too simple. But it's worth because they solve problems for industry and real clients. So this, unless you work like in a big tech or some startup, you have a date in your company. That's not the case of IBM, for instance. So we have like client data, and we cannot use this client data to publish. So when you work in academia, you do like a research, and you create, for instance, let's say a new architecture of a neural network, or you solve like the problems like images and so on. Of course, this is very worth, and we need research, we need the academia, we need everything. My point here is what are the type of projects that applying research or industry research can solve client problem and also publish in a conference. So the differences between these is because sometimes when we work, we came from academia, we know how to work like with data that's already clean, so it's public data, someone already cleaned the data. You just need to develop machine learning. And when you work with real clients, you need to work in all the steps. So we need to extract this data, we need to clean this data. Sometimes you cannot crop this data, removing parts that doesn't fit your, the outliers, because these are important problem that you solve. And the main point is that most of the time what clients needs is a very simple solution. So we can solve sometimes like 75% of the problems are classification, and you can solve like with XGBoost. Sometimes you don't need even a neural network. Of course that you have very big problems, and sometimes you need these to create innovative solutions. But at least here in Brazil, what we're seeing is that the problem is behind, is before machine learning, is before data science. So they have like data disconnects from several business units, the data in silos. They have a very new data science unit. So you need to build everything until you can do really cool stuff in machine learning. And this type of work, it's work for the clients, it's work for IBM, but it's hard to publish. So because you're not doing a breakthrough, you need to work like in scalability, you know how to tell the story, you know how they'll have time to deliver the solution, so you don't have extra time to invest to create a more like innovative or more, let's say, go deep to the problem and create like a different solution. So but what this talks about? So here I'm talking about a project that I was part of the team when I was in research lab here in Brazil. And that is very applied to the industry. So this can solve real problems of the clients. This can improve products. And this is also a research project and it was published in several top conferences. So this is my goal here is to show ideas or this is a specific idea on how we can connect like industry and research and publish and make the difference. So the name of the project is Make Machine Learning Classification Work with Human-Friendly Definition. These are the teams. So Claudio Pianese was the manager leading this project. I was part of the team, and Paulo Cavalin was the main machine learning guy responsible for most of the things that I will present here. So we have like 3 papers published in MNLP, in Chi, and ACL. So what's the context? So we know that chatbot is all over place. So everybody has assistants, most of the clients have chatbots to automate clients, call centers, and like bankings, telecoms, and so on. But the problem with chatbots is that it's still very manual. So, I mean, you can work with text mining with the corpus, but you need someone to create that. You need someone to infuse the data. So you need someone to structure that knowledge. And this work is about how you can find new examples and intents for chatbot logs. Because these logs are things that you need to work from time to time. So you need to work in these logs to add more examples for your intents or create new intents if your chatbot does not answer correct for some questions or if it's something changed. So if you get like the definition of a class, we add sentences, in this case, type of questions that are similar for the same class. So if you have this intent, get balance, credit card, you put all the sentences that you can answer with that. So what is my credit card balance? Tell me my credit card balance. I want to know the balance of my credit card. And if you have another intent, you can add different sentences for that. So this is a traditional machine learning system when you add sentence, and the sentence are very similar. So you have like the similarity function. But naturally, humans do classification. We do classification most of the time. When you put the clothes on your wardrobe, when you sort some elements or you organize your stuff, and you can do this in different way. You can use examples, you can use the symbols, you can use in taxonomies, you can use in hierarchies or features or counter examples. And here, based in our previous example, I give you some of this context. For examples in the case you give like similar sentences that answer the same questions. For symbolic key sentence where the user asks for the balance of her credit card. So taxonomy, you can use the words like get, balance, and credit card. For hierarchies, you can organize like, let's say, get balance. So get balance from credit card or get balance for your account. Features, you can use like the keywords like what is, balance, credit card, how much, and so on. And counter example, you can give like sentence that are not the way you want to do that. So our main hypothesis is that people that when you start to create like a chatbot, they organize this knowledge in graphs, even then they don't know what is a graph. This is one example. So I can structure that this knowledge of a client, get account balance, get credit card balance, or invest using a graph and create based on this work. So we can use like a knowledge graph, for instance. And we can use like a multiple defined class interface. Suppose that you can have like this interface, you can use like different ways to organize your knowledge and to classify your examples. So you don't need to use just examples, you can use like keywords, taxonomy, or descriptions. But then if you use that, you need to change your machine learning algorithm. So the traditional way, you have like the text data, you create the sentence embedding, then you apply like a softmax function or any other function, and then you have your classification. But in this case, you can combine like your sentence embed with like a graph embed and have this error function to measure how much error you are getting. So how we can how to do this classification using classes defined by both examples and concepts. So this is the traditional machine learning algorithm. So you have like an input, you have like a way to create an embed of your input. So you do some sort of classification using a neural network or any other algorithm. Then you have like output vector, and then you have like a function, and you get the class label. And you can do this with training and get this example and adjust the weight of your network. When you use this concept, instead of you have like, when you have like your embedding output, you can embed the in space for class concepts. And then you have like a nearest class detector that you give like an error or any other similar measure. And then when you have like this new system, this is the way you add this class concept in your architecture of your new classifier. So you have like this input, you still have like the embed of your sentence, but now you also have like this concept embed, and you can adjust the error and also training. So you have like this hybrid machine learning training system. And these are related with zero-shot learning, that at this time a learner observed examples from a class that were not observed during training. So now you have like examples from a class that you don't have in your training data set. So you can using this label embed space is a standard method using zero-shot learning. So you now want to see how much your work your machine learning training is getting this zero-shot learning accuracy or error in this case. Using also this knowledge graph or this graph, or we will say that we now we call this like Prototaxonomy. You can use like the work from This is an algorithm for a reverse dictionary problem that is given a sentence definition. I want the concept. So what's the concept related with these examples? So the output concept is represented as an embedding of a knowledge graph, in this case of this work. So now we have, in our proposal, we have like embedded different space of concepts. So we can embed like the keywords. So we create a graph with the intent name and attach to this node with intent name all the words, the keywords from examples, from the sentence examples. And then we perform like a deep walk to generate like random walks and generate a graph embedding. So we can embed the taxonomy. That the difference, instead you create like the node with an intent name, you will break the intent name in the main words. So get a balance of my credit card. I have 3 nodes, or actually 2 nodes, get, balance, and credit card, or 3, get, balance, and credit card. And then we attach the keywords more relevant to get, to balance, and to credit card in each one of the nodes. And we have like the path to be an intent, and then we generate a graph embedding using also deep walk and random walks to generate that. And we have like embed description when you choose a pre-trained sentence embedding algorithm, like use your CDSSM to determine the embed of a description using it as an input of the sentence embed. So we have like the description, what this intent means, and we generate an embedding of this description. And where to find data for machine learning classification with dually defined classes? So how we can find data sets that we can use to test that idea? So First, we need to define our do example plus concept perspective. So this was a research project, as I told you, using real data from clients that allow us to use that. And we have like three types of dual class definition. We have like examples, sentence examples plus keywords, examples plus taxonomy, examples plus description. So E plus W, E plus T, and E plus C. And we have in this side we have examples of the data that we use. Examples are the sentence, keywords from this example sentence, and taxonomies, as I said, the name of the intent. And description, we have like a sentence where a user asks for balance of her credit card. So when you have like this professional chatbot development tool, so we have like you create all the intents, and then you give some examples of your intents, and then you have like a machine learning algorithm for classification. And every time that you use and send a sentence for the chatbot, you get a classification for these intents. So user need to give this name for the intents that are the name ID. And we saw that most of the users, when they are working this name ID, they use like what we call like a prototaxonomy, because it seems a graph, but it's not a real knowledge graph. So it's more like a taxonomy for the names, but it's not really that. So we can say that's a prototaxonomy. So we saw that when the users are using like Watson Assistant platform. And then we did some experiments, some user research to see if this really happens in real. So we did this workshop with developers and curators. We did 4 design workshops. And we saw that they really organize the knowledge in this way. So they have this in mind, and it's more intuitive, and they really do this. So then to see if this really happen in a more volume, we get some workspaces from people that when they using like Watson Assistant, they mark these workspaces that you can use for research proposal. And then we have like competition. So we get these workspaces in English and in Portuguese. So almost 4,000 workspaces in English and 3,000 in Portuguese. And we create this metric. So the taxonomy rate, that is the ratio between the number of intents with taxonomy and the number of intents created by the user. So to see if they are really using that. And you saw that we have like 15 or 20% of the workspace with more than a rate more than 90%, and rate above 50%. We have like half of the workspace in English and almost 40% of the workspace in Portuguese. And if we have like a lot of workspace, even with a few prototaxonomy. So at least, I mean, more than 10%, more than higher than 10%. So you have some sort of taxonomy there. So then how we can mine this? So we get some of these workspaces, and we have like the examples, so the name ID, and then we create like the keywords from the examples. We get the taxonomy based on the name IDs, and this was the tough part, because the main problem here is to find the best separate. How do we split that? So what is the best way to split this name ID based with this separator? So it's not that trivial as our example here. And then we mine this description. So for each intent, we can convert the name ID to a sentence simply by using the best separator and replace it with some space. So from the name ID, we can create also the taxonomy and also the description. And how this classification work? So how it work? So the focus is text classifiers, so intent action chatbot, and we did this as a problem, as an out of scope problem. So users do not know the knowledge of the chatbot, so they may challenge and ask a question they don't know if they can answer. For instance, if I have a chatbot about health, I can answer about the diseases and virus. So I can ask for coronavirus, okay? But if I ask about the computer virus, it's not the same because it's a totally different topic. So this is totally out of scope. So this is our inference, our architecture, and we have like four versions. We have like LSTM with a baseline and use it with the baseline, and then we have like LSTM plus W that are the keywords. Using plus W, LSTM and using plus T that are the taxonomies, and LSTM plus C and use plus C that are the description. And our evaluation metrics are basically the ones using out of scope. So we have EER, we have FAR, we have FFR, and we have in scope error rate. And we can see the FAR is this threshold, this point here. So let's see. For of course, for publication, we didn't use any client data. We are using in this case like Larson. That's a public data sets that's a benchmark and anyone can use. So we have like 1,000 out of scope example, 22,000 in scope samples, and 150 class, 150 examples per class, 18,000 training sample, and more than 4,000 ES test samples plus 1,000. And you can see that in this case, they use perform better than LSTM. As I told, sometimes the simple is better than even a deep learning. So, and we have like a dramatic improving out of scope detection by far. So we saw that use perform better than LSTM, and we have like LSTM plus C with a very high error rate. So and you see that the user has a user plus T and user plus C low error rate here. So here is another data set. So we have this telco data set. It's a little bit small, but we can see that use and LSTM have similar performance. Some improvements in out of scope detection with FAR and user plus T and user plus C. So we have like a better result again with user use. So, and then we got all that massive corpus that we have of chatbot, and instead to report each of them, we actually make like an aggregation. So first we got like 200 workspace from a professional platform repository, and then we simulate this out of scope. So we get like 20 samplings when 5 intents are removed and all their examples are considered out of scope. And then we compute the difference with the baseline using and each of these 200 data sets. And you can see that you use plus W, that are the keywords, it's better in FAR and EER and in ESER, and use plus C similar in FAR and EER. So we saw that 71% of our workspace had some improvements in FAR with use plus W, and for the other metrics we have around 42 and 43%. And for the second experiment, we selected an 161 well-defined and well-developed and more complex workspace. So instead of get something random, we went there and get the best one. And we did the same. So 20 samples where 5 intents are removed and other examples are considered out of scope. And we see that in this case, we went better. So we have like 80% of have some improvements in FAR, but also with using use plus W that are the keywords. And we have more than 56% improvements in the other metrics. So, in conclusion, so our finds is that using this dual defined class improve accuracy, so it's a good way to develop and improve machine learning classification, especially for chatbots. It's not applied to ever to all workspace because depend how these workspaces are created. We have like impressive gains in out of scope, and this chatworks was not developed to out of scope. They are developed to get accuracy. So so we have like this kind of limitation. And keywords like using plus W yield the greatest gains, followed by the description, using plus C. We still have some work to do, so we're using like a fixed dimensionality of concepts, and maybe this is not optimal for this workspace. So, as I told you, my idea here is to present a work that it's very applied to industry, so we can really apply this and have more knowledge on how to develop chatbots and how improve the knowledge for create this chatbots. And also, it's a very work that was published in several conferences. So we have the papers, and feel free to get it and read it, and I will be available for questions. Thank you very much.
Hi, Anna. Thank you for the talk. I do have a question.
Sure.
Do you have any advice on people that may not be working on these big tech companies, on how to position the research that they do, or the problems that they solve, so that they can engage more with the research community?
I think that a good advice is for engage with like the research team, even if you don't work in a big tech. Is try to attend like workshops like this, because now most of the data science conference, they have like industrial tracks, like for example data science DSAA. So they have like industrial track to try to connect industry and research. And you see a lot of practical cases, because sometimes when you work like in a real project, you don't need to advance the state of the art. You need just to apply. But this is interesting too, because imagine that you are a research and you saw your work, somebody put your work in practice. So I think that this should be very interesting results. I would love to see some of my papers that are from a conference that people are using that in real life. So I guess that this would happen. So this could be like a possibility to try to send and attend. I think that with this pandemic situation, the things start to allowing this, because I mean, with this virtual event, so people can attend even without traveling. So make the conference more reachable also for people that do not have like a master or PG, or is not a research. Would be interesting to promote this.
Well, in that case, I also have a question. How likely is that when we see that more enterprises are also setting up their own research labs, how can this like alter the state that is currently working the research in the academia and their relationships with the business side?
I think I didn't get your last part. So the research team.
Yeah, you see, like the business are starting to set their own research centers, like Google with DeepMind and many other places that are having their own teams to build research. So is this going to affect the way that right now research is done, or how, or if it is possible that these new relationships can help in further increasing the like the synergy between the companies and also the academia?
Yes, I think so. I think I mean, when we have like other companies, even in Brazil, we have some startups that they start to hire more PhDs. So we saw this tendency in the couple of years. I mean, with the lack of find data scientists, at least I saw this in Brazil. And because of this, most of these PhDs wants to publish in conference. So I saw, for example, last year, I think the people from iFood published in NeurIPS. And I saw other, not only big companies like Google or IBM or like Microsoft or Facebook or but also small startups trying to put their work there. And this is very interesting because you can see they try to work, applying state of the art of the work in the business. And this is very relevant. Even me, now I move from a more pre-sales unit. This is not a research. But I finished my first project with client, and I talked to the client that's a bank here in Brazil and say, oh, wow, why next year we can publish this work, because we did a very different way. And he was very excited to publish this. But banks are a little bit more complicated because they have a lot of confidential stuff. But I think that's the way. So when you have like people that come from research to work, even not research unit in a company, you can start to see this happen. And I think that's a good move for industry and for academia.
Cool. Okay. I have a question from the chat. They are asking, what are your thoughts on how to evaluate when the classification is not correct due to outscope versus closer content that may not answer the posed question?
So this is a very tough question, because now most of the, I mean, we saw this when we use like assistants, cognitive assistants or chatbots. So I think that we have some questions, especially depend of the language that you are using, that you can see that. So one thing that we tried to do in this work was saw how close this, these clusters, these intents are, and maybe propose some slightly difference that you can adjust this. So instead of because this is close and it's not out of the scope, so it's too close. So you try to create like a different separation. So you will put the right question, the right intent. So you are creating like extra knowledge, so the chatbots can be able to separate that in a more efficient way, and it's not just a basic classifier. So add more knowledge. It's right path. I mean, of course, that everyone wants to a chatbot that can learn based on language or NLP, but we know that's very hard. So even use knowledge graphs. So we are not there yet for chatbots. But maybe if you add like a little bit of extra knowledge that you have when you create this, you can be more effective in the way the chatbot will answer the questions.
Okay, I got another question for you, Ana. What are your thoughts on how to train a model where the training data have a lot of confidential data?
Let's see. So how to train a model when you have like a lot of confidential data. So I mean, when you have like this the way you have like some models that you can cryptograph your data before your training. So if I'm not wrong, there is this work on Zurich lab from IBM, posted I think some couple of years ago, and they have like something like this. So they encode the data before you're training the data, so you can don't see the training data, the confidential information, or you have like other stuff there. So this is a very interesting question. We are in a project now that we cannot access the full data of the clients, so they need to pass because they have like different architectures and they have like this confidential data, and they need to mask all the data before, and they, I mean, encode in a way before they go to this other architecture that has the chatbot. And also, based on the previous questions, they have this problem because when you create like a new intent and you put new examples, they need to test all the intents in the whole production environment to see if it's not conflicted with other intents during the question answer, the whole system. And they have like this massive chatbot. So this is a very problem. I mean, how you can separate this. So, and if they have like this, we need to work like to other artifacts, like avoid jumps to go back in the conversation, or just isolate the intent. So in real life, there's this question of separate content in chatbots. So don't misclassifying the question that the user are posing to the chatbot. It's a very important one. So.
Yeah, actually, yeah, you're true. I find quite challenging the fact that for being able to personalize more the responses of a chatbot, you have to be able to gather the data. It sometimes can be quite sensitive also, like being able to do this workaround to get the context only and managing for the chatbot to be able to respond and adapt to the situation. It will be, it seems interesting. Cool.
Yes.
Yeah, I don't have any other question on the chat. Well,
thank you very much for having me. And if anyone wants to connect or ask any question offline, just connect with me or send an email. So I'll be glad to answer.